All right, so we've put together a XY scatter plot of our variable of interest, completion time, versus the number of pieces that are part of our job. And then we fit a regression line to that, getting the equation of the line and the resulting R squared. We can also generate that same regression model in other methods within our spreadsheet or other statistical packages. So here we have output from Excel generating those regression parameters in a slightly different format. Here we'll see we have our R squared, we have our intercept, and we have our coefficient for pieces, but we also have a lot of other information. A key piece of information that we're going to focus on here are the p-values for both the intercept and the pieces coefficient. These p-values, or probabilities, are statistical measurements of the significance of these coefficients. We have to realize that we have this sample that we've built our regression model with. And this is just a small subset of all possible jobs that we might look at building regression models on. And we're trying to use this sample to make inference about a future job. And so this model is we're trying to generalize from this model about all past, present, and future circumstances for our shop floor. And so because of that, we have to be cautious about how definitive of statements we make based upon the parameter estimates that come from this sample. So yes, they are a fact based upon this sample, but we're trying to generalize from this sample to the overall population of potential values. And so in our statistics world, we typically have this thing called hypothesis testing, where we kind of set up the opposite result we're trying to find, and we basically prove that the opposite result is not true, which provides support for the thing we're looking for. So in this circumstance, we're trying to find a relationship. So the opposite of that is that there's no relationship. So that would mean that the coefficient for pieces as part of our regression equation is 0. And what we simply do is statistically we estimate the probability that, given the sample we have and the estimate from the sample, that the population value could be 0. And here, for our sample, that probability is really, really small. And so basically from that, we can gauge that there's no chance or very little chance that there is no relationship, which provides support for the relationship that we found, right? And sort of adds confidence to us that this model is valid, and in our statistical world, we say that we have statistically significant results, right? So we have some model, we can reject the idea that there's no model, which provides support that we have some model, right? And so one of the things that we look at from either a regression-based output from Excel or any statistical package is we look for this thing called p-value or probability, and we basically want that number to be less than 0.05, right? So we have this 5% critical level. So as long as there's less than a 5% chance that there is no relationship, then that means that we're comfortable saying there is a relationship, right? We're not saying that it's exactly this, but we're saying in our case, our parameter estimate is not 0, which provides support that keeping pieces in our model helps us predict completion time and reduces that uncertainty in the overall completion time.